Hi guys, so I am Saral this side. I am introducing you to the new concept of system hashing. So this is one of the new terminology that is being getting used these days. A lot of applications like Uber, Swiggy, they are using it to make their distributed systems more scalable, and they can serve and they can have a better user experience with the customers and in terms of processing at a backend. So let's see and explore it, and guys, let me know your feedbacks over it and what do you think I can improvise it in. But a small disclaimer, this is again based on creativity, but the concept of consistent hashing which is getting applied on system designing is being the same across. Okay, so when we say what is consistent hashing, so I told you that it's just to improvise on the scalability of the storage systems, where we see that there are a lot of data which is being getting distributed these days. For example, if you are using Uber, so they have tried to place their server maximum to the nearest region location center where they see that a lot of traffic has been introduced. They have started having a replicas of them, so to have a better scalability options to produce much more faster responses to the end user customers, so that minimum latency is there. Okay, so the number of available server they can get changes, but normally consistent hashing happens in a ring topology, as you have seen that we have placed machine 0, machine 1 and machine 3, and we have different keys like k1 k2 map to machine 1, where you can see in this picture. So the logic of placing k1 and k2 to machine 1 is being decided on the hashing function which we are going to study in this slide. And we need a simple hashing function which I have shown you, so to we decide which keys to map to which server locations. Okay, so let's study about consistent hashing. But first of all, what are the benefits of using a consistent hashing? As I told you, it's a useful strategy for distributed systems, because these days a lot of microservices architecture platform that we are moving, but we deploy our services to the multiple regions. Okay, and we want kind of CDN networks that we are using, where we are placing a lot of static data to have a better response time and user experience. But similar kind of things, that is consistent hashing, where we say that we know the targets where we know the traffic is higher, and we have placed our servers to those locations in this topology to have a better interconnectivity and to get a better response. Okay, so it will allow us all this consistent hashing, because the word distributed systems have coming up. So you can say that distributed is also coming up to the cluster level. So clusters are being formed in which server machines are being placed at a certain positions depending upon their IP address allocation, or hashing function is applied on that, which detects that on cycle on which location these servers will be getting placed on. And then how can we uniformly map keys so that neither of the server may get overloaded and all of them get a uniform distribution across the topology or across the clusters. Okay, so in this way our caching systems can be easier. We can scale it up or we can scale it down. And in consistent hashing, we can say that objects are mapped to the same host as it is possible. When host is removed, the objects are shared by the other host. For example, if I'm showing that this is one of the cluster topology, ring topology, where you can see that there are the 4 nodes, and there are corresponding keys are being getting mapped to the each node. But let's suppose if there is some reorganization happens, and I say that I wanted to delete the node because I see that I can go ahead better in performance and I can utilize it better in any other architecture point of view. So I need to map earlier D, which is getting mapped, now it's getting mapped to node A, which is the nearest neighbor. But again, a hashing function is applied over this, which detects that node is A is the best candidate to serve it. Okay, so now moving it to next is why simple hashing. Simple hashing is just because I don't want to go over this theory, because where I have told you that what is you can even Google it out, that what is the hashing function, that simple hashing function is applied. But reason point of let me tell you that we have not used, or we have to overcome from the simple hashing mechanism, because in simple hashing the distribution of the keys that happens when you're going to add a node or when you're going to delete a node in because this is going to be happen out. Obviously, you at some point of time you maybe scale up or scale down your systems depending upon the traffic that you are going to receive. So at that point of time, hashing is applied to all the server machines. Okay, not only to the machines or two adjacent or three machines which you are disturbing, but it will get applied to overall the machines which is involved. So which is kind of, you can say, a sort of disadvantage which I see normally. Okay, because why to disturb all the nodes in the clusters which are already being settled out. So I see a disadvantage in doing that activity. So let me show you an example earlier which we have seen. So I have tried to apply this formula where I've seen that there were the number of servers 3 and we have a 6 keys, and these are the 3 number servers, and on key we applied the hash function, we get this value, and then how we have stored this. Okay, another problem arises where I try to add one more node. So I try to add one machine. Now n become 4, earlier n become was 3, where the number of machines were 3, and here the number of machines were 4. When we applied, we can directly see that machine 0 is getting ununiformly distributed, where a lot of load is coming up on the machine number 0. A lot of keys are mapped to this. Now this mapping is decided by hash function, where we cannot bring more changes. Okay, same kind of problem arises when we try to remove a server. We remove the latest machine that we added, and we see that again, keys are ununiformly distributed. So this create a problem for when we are trying to add and when we are trying to delete. So what we have done is that we say that consistent hashing will help us in achieve to the system, where we say that minimum number of reorganization. This is the line which is a CASI, where we say that minimum number of reorganization is minimum, and that is the magic of your consistent hashing, because it does not disturb all the nodes in the cluster. It just only disturb the nodes in the cluster, or 2 nodes or more than 2 nodes, for where you are reorganizing the things in between. It doesn't disturb the all previously settled nodes. So that is something which is I like about consistent hashing. So let's see in the example. We have to find the positions of a machine. So what we do, we take a hash of IP of all these machines, and we take a hash of all the keys. So we have got a 2 keys, sorry, we have got a 2 hashing. We got a hashing of IPs of the machines, like machine 0, machine 1, machine 3, and we got a hashing of the keys like K1, K2 and K3, and then we placed them on the server at the calculated positions, and then we see that map key to the server which has the same hash value, and we try to map the keys to the server which has the same hash value. So we have a hash value of machines, we have a hash value of a key, and then we place some combo and we try to map these things. Okay, we try to map, for example, if by chance K2 and machine 1 has the same hash, so we try to map these things. So in case of key hash value doesn't match to the server, then we map it to the nearest. For example, if say K3 is mapped to machine 3, so this happens in a clockwise direction. We will see it out another scenario. So if I try to add one more machine, then let's suppose if I try to add machine 4, so then hashing will be applied between machine 0 and 1. I do not need to disturb machine 3. That's what I'm trying to say in this slide. So I have to place the things between machine 0 and machine 1. So as a result of adding new servers, we don't have to rehash all the keys. We don't need to disturb the machine 3, which we were doing it earlier in simple hashing. So that is a catchy point. Okay, so instead we only look the things between server 0, 1 and average real time. Okay, so this is a significant improvement over the simple hashing. Okay, and similar case while you are removing, as you can see that I am removing machine 2, and in case of something goes down, the server goes down, because this is a clustered environment and system design that has been going on. So then what happens is that we try to store the key which was being getting earlier stored by machine 2 into the clockwise direction into the nearest neighbor, to make the infrastructure as a availability part of CAP theorem. So non-uniform distribution, yeah, it can be happened in consistent hashing also. Earlier you see that particular machine get overloaded with a lot of keys. This is the same which is being shown here, that machine 0 get loaded from K4 to 8 keys, which is a non-uniform distribution, whereas machine 1 have only K2, K1. We can say that non-distribution. So what consistent hashing done to overcome from this, they created replicas. For example, machine 0 was overloaded, they created replica of machine 0 here, they created machine 0 here, and then they try to map the corresponding keys machine 0 just to uniformly load balance the things to machine 0, and they also created replica of machine 1 and they have tried to distribute it. So this is one of the smartest ways, is that number of instances of every machine is increased. They have started replicas, so load balancing, scalability, and availability is high at this point of time. Okay, they have seen that we introduce more replicas of servers to get a hash different value, which means more machines are placed and a number of these replicas in the distribution become more and more uniform. So guys, this is something about short inconsistent hashing. There are real practical live example scenarios where I have told you Uber, Swiggy and a lot of things have been using from scalability, from cluster, from availability point of the CAP theorem. So guys, this is something which we know about consistent hashing and we have learned it today. I will be coming up with more videos on system design. So thanks for your time, and yeah, I really appreciate and let me know your feedbacks over it. Okay, thank you, thanks for time.